Okay, so this is the review the district provided for us. So I expect to see very similar questions on the exam, but I don't only expect to see these questions because a lot of times they put like other stuff on there too. So that's why we're kind of doing a little bit of both. But I would definitely expect to see questions like this that are formatted like this on the exam. Also, for these questions, I put some similar ones on Alex this week, and you'll recognize that as well. So when you see those questions on Alex, just know that those are similar to what you'll see, and it's good practice for the exam. These questions right here on this page are all transformations. And that's when you're like moving a shape on the graph. It's all rigid transformations. So rigid transformations means like the shape isn't changing size at all. Rigid transformations, like it's the same size and shape. Same size and shape. Like nothing about the shape is changing, it's just moving location. Oh, sorry. Rigid transformations, same size, same shape, it's just moving location. And when we do move shapes, remember, like, yes, you're moving the whole shape, but really what we're looking at is just like point to point. So like point D is the original, and then D with this little mark is D prime, and this shape is going from like this to this, or this point is moving from here to here, G is moving from here to here, E is moving from here to here, and so on. So that's how we'll be looking at it. So it says, which of the following statements correctly describe a transformation that maps quadrilateral DEFG onto DEFG prime? So the best way to do this is to go through each answer and determine which is best, especially since it's a select all question. So it says a translation, write one, down one. So you just choose a point like D, write one, down one. Is D prime right there? No. So that is not correct. But be careful though, because if you started with F by chance, if you go write one, down one, it does land on F prime. So make sure to check more than one point because they will do that on purpose. Next one, it says translation left 5, up 5. So if I moved like E, left 5, up 5, E prime is not there, so it's not that one. Rotation 90 degrees clockwise about the origin. So if I was rotating this shape, a 90-degree rotation would actually put it down here. Also, another way to check it is you're rotating about the origin. So you should be able to draw a line to like corresponding coordinates. And if it's a 90-degree rotation, that should be a 90-degree angle there, which it's not. So it's not that one. And then the last option of those statements, a reflection in the line y equals x. So the line y equals x is like a diagonal like this. And if you're reflecting a point over that line, it should be the same distance from that line on the other side. So like G and G prime are both, it looks like half a unit away. D and D prime looks like that's the same unit, same distance from that line. E and E prime. So this is definitely one of the correct answers. Then it has answer choices that have us looking at the coordinates and like the coordinate rule or how the coordinates are changing. So for that, I would quickly just like grab the coordinates off the graph so you can look at it. D, F, G. And then you can use the graph to find the coordinates, but I might shortcut it a little bit because I have it written down. So like point D is at 2, 8. You could count, but I'll just tell you. D is at 2, 8. E is at 0, 5. F is at 2, 3. And G right here is at 4, 5. And then we have D prime, E prime, F prime, G prime. And then these new coordinates, D prime is at 8, 2. E prime is at 5, 0. And you may start already noticing a pattern like X and Y are switching places. Then 2, 3, and then F prime is at 3, 2. And then G prime, just based on the pattern, I know it's going to be at 5, 4, and I can kind of check that. So it looks like if this is X, Y here, it's changing the order to Y, X like that. And then when I look here, that's actually the first choice right here. And then I just, because it's a select all, make sure the other ones don't really make sense. Plus 5, no, that's not what's happening. Nothing's turning negative, so not this one. And then -1, -1 doesn't make sense. So it does take some thought. but you can do it. And that was a level 3 question, just so you know. And then the next one's level 2. So it kind of goes down. Okay, so level 2 right here, but similar question. It says, which sequences of transformations map one triangle onto the other? Also remember the order of these letters, like these correspond. So A corresponds to D, like B corresponds to E, and C corresponds to F. So we can use that to help us too. So we'll just go through each answer choice. Again, there's really great practice with this on Alex that's just like this. So we're trying to see which directions map this shape onto this one. So reflect over the x-axis, then reflect over the y. So if I take point A, reflect it over the x-axis, and then reflect it over the y, it does land on D right there. Cool. So if that works for all the points, then that's my answer actually. So then B, reflect over the x, 1, 2, 3, and then reflect it over the y. So same distance on the other side, and it does put it on E. And then C, reflect it over, and then over, it puts it on F. It just so happens that this first answer is the correct one. The other ones, if you follow the instructions, it doesn't map it onto that place. So like, for example, this says reflect over the x-axis and then 4 units right. B would not land on its corresponding point, and so on. So these are not correct. Okay, next. This one, level 3, so it's a little bit harder than the last one. It says, which sequence of transformations maps A, B, C onto D, E, F? So again, like the first letter corresponds with D, middle letter corresponds, and last letter. Because we're working with coordinates, I'm going to grab the coordinates of A, B, C. So we're going to have A, B, C, like that. And A is at -2, 6. B is at -2, 2. And C, 1, 2, 3, 4, 5, -5, 2. Okay, so now what I'm going to do is I'm going to use these steps, and it's tedious just going through it one by one. Step 1 is to change the coordinates like this, so it becomes -yx. So this would be -6, and then x just stays the same. So this is 4a. And then add 8 to the x, so that would be +2, and then y just stays the same. And then I'm looking for that to be point D. So 2, -2. It actually is point D. So this could be a correct answer. I'm going to go through the same steps for B just to make sure that it works for every point. So if I take B, which is -2, 2, and follow this rule, I would get -2, -2. Step 2, add 8. So that would be 6. And then y stays the same. And then 6, -2. It works. That's actually E prime. So we're good. Or E. And then F, if you wanted to be really go through all the steps, it'll give you the point for F. So it just so happens first one is correct, which is nice because that is tedious, but you may have to go through more than one answer to get it. Okay, it gets easier again. Level 2 problem next. Okay, so level 2, it says, given the shaded figure on the coordinate plane below, which graph shows the correct transformation of a reflection of the figure in the x-axis? So just kind of reviewing, if you have a coordinate plane like this here would be the x-axis. This is your x-axis, right? This would be x and y. If you're reflecting a shape over the x-axis, so let's say that you have a triangle like this, what you're doing is you're taking each point and putting it the same distance from the x-axis on the other side. So like this point would reflect like this one same distance away on the other side, this point same distance away, and you reflect the whole shape like that. So you're essentially reflecting each point. So in these examples, that's what we're looking for. We're looking for one where they reflected the shape over the x-axis. Okay, so for example, this one, if they reflected this shape over the x-axis, my shape should be here, and it's not, so this is not a correct answer. If they're reflecting this shape over the x-axis, it should be here, and it's not, so nope. This one, if they were reflecting this, it would be more like here, and it's not there, so no. And then this one looks a little bizarre, but if you look closely, C is being reflected right over the x-axis to get C prime. J is being reflected over, same distance from the x-axis. M and M prime, same distance. K and K prime, same distance reflected over. So this is our correct answer here. And then one more question on the other side, and we're done for today. Okay. Here, this one, and it's a pretty easy one too. It says level 2, so that is nice. I also assigned one like this on Alex as well. It says ABC is transformed into DEF using rigid motions. Rigid means like the shape isn't changing, like the size isn't changing, it's just changing location. Put a check mark in the appropriate box to identify corresponding sides and angles. Okay, so these statements right here tell you what corresponds to what. So like the first two letters here, AB, correspond to segment DE. So AB corresponds to DE, or like AB is the same length as DE. The second two letters, BC, would correspond to second letters here. So BC corresponds with EF. So BC corresponds with EF, and they are the same length. And then the first and last letter, AC, corresponds with D and F. So this here corresponds with DF. Okay, and then here it's saying put a check mark in the appropriate box to identify corresponding sides and angles. So AB right here corresponds with DE. So I'll just put a check mark there. BC, the green one, corresponds with FE. CA corresponds with FD or DF. Okay, and then as far as the angles go, kind of same process. The first letter corresponds with the first letter here. So A corresponds with D. So A is the same measure as D. And the middle letter B corresponds with E. And the last letter C corresponds with F. So C and F. Okay, and then this problem right here underneath, they took this off the exam because we haven't learned that yet. So just cross that one out. Okay, that's all for today. So you have the last 32 minutes to start your homework. So grab a laptop, get as much as you can done.